In convection internal flow, we have solved problems based on turbulent, laminar, and then internal flow non-circular, and then liquid metal. We will solve it now. The remaining things we have already solved. So we will solve this liquid metal problem here. So first thing to identify here is that there is a liquid metal. Okay, when he is written that it is a liquid sodium, it is a liquid metal here. Okay, so you have to take a liquid metal kind of material and then solve it. And then what is the next thing? It is to be heated from 120 degrees centigrade to 149 degrees centigrade. So next thing to do is in an internal flow problem, flow problem because in a 5 centimeter diameter electrically heated tube has written. Okay, written it's the tube, so it is an internal flow problem. Once you understand that it is an internal flow problem, what is the next thing to do? I have to find out the bulk mean temperature. So here the bulk mean temperature can be found out using this 120 and 149. Also is given this 2.3, 2.5 centimeter diameter, and so many things is given. Let's write all of them. Is given the T inlet is 120 degrees centigrade, and then he also gave you 149 degrees centigrade. That will be T out, and then what else is given? Kg per second is given 2.3 kg per second. It is m dot. Okay. And then diameter is given is 2.5 centimeter. What else is given? It's a constant heat flux problem. It is given. This has to be taken seriously. Then it's asking you to calculate the length of the tube, minimum length of the tube, if its wall temperature is not to exceed is given. So what is asking? Is asking you to find out L value if the temperature of wall is 200 degrees centigrade. Okay, this is what is given. So using this, you can find out the bulk mean temperature. The bulk mean temperature will be like 120 plus 149 by 2. So somebody please calculate and tell me what is this value.
134.5.
134.5 degrees centigrade. Okay, that is the bulk mean temperature. So what you have to do at 134.5 degrees centigrade, you have to take the properties that are required for you here. Okay. So how will you find out the L value here? You'll be finding the L value only if you can find out the H value. That is, what is that H? The H is heat transfer coefficient. So first thing to find out here is the heat transfer coefficient. How do you find out the heat transfer coefficient? You will be finding out using the Nusselt number correlation that you get from the data book. Okay. Before you go to the Nusselt number correlation in the data book, what you have to do? You have to check whether the flow, the given flow, it is a laminar or a turbulent flow. You have to check. So for that, what you have to do? You have to check the Reynolds number values. You have to calculate the Reynolds number value. For that, you have VD by mu. This formula you can use. Since m dot is given in question here, so what you can do is you can use this formula 4m dot by pi d mu you can use. So in this, you know, m dot is 2.3, and then pi. T value is 2.5 centimeters given, converted into meters into 10 to the power of minus 2. Mu value is not known to you, so you have to get it from the data book. So from the data book, the mu value has to be found out. So go to the data book. So in your data book, go to the properties. In properties, I'm actually looking at this index. In index, you can see that there is a title called liquid metals. Okay, it is in page number 40. So move to page number 40. There you will find properties for liquid metal. So move to page number 40 in your data book to 7 40. Here you find the sodium thing. Can you see the sodium value now? This is how the sodium values will be like. So here what you need is 134.5 degree centigrade you need. Okay. Actually speaking, we do in between. If it is there, we do interpolation. If it is outside, you will go for the extrapolation. So do the extrapolation and get the values that are required for you. Okay. Here you don't have the mu value directly. Mu is not known to you because it is not given here in the list. So how can you get this mu? Mu is the ratio. It's not the ratio, it is the product. It's the product of rho into nu. Okay. So rho into nu, that is the rho into nu will be giving you the mu value. So dynamic viscosity is the product of kinematic viscosity and density. So you have to find out these two things. So for this, again, you have to kind of extrapolate. The procedure is similar for both interpolation and extrapolation. You have the value for 150. I'm finding the row first. Row is 150 here. Sorry, row is 91916. For 200, the value is 903, and you need it for 134.5. The procedure is same. So you write like 200 minus 134.5 by 200 minus 150. Whatever you want, you can write it on left hand side, and the corresponding values you will write it on the right hand side. Same logic you will follow. 903 minus, let's call this x by 903 minus 916. From this, tell me what is the x value. This is again, I remind you, this is a rough work. Tell me what is the x value. Can you calculate it? Please calculate and let me know what is the row value. Similarly, you should also get the new value. So for getting the new value, 150, 200, right? 150 is 0.594 into 10 to the power of minus 6. And then for 200.506 into 10 to the power of minus 6, or 134.5, you have to find out the x. That's 200 minus 134.5 by 200 minus 150 is equal to 0.506. I'm taking out this 10 to the power of minus 6 as common. I'll take it at the end. Uh, Minus x by 0.506 minus 0.594. So get the x value here also. Tell me what is x value in both cases. Calculate the x value and tell me.
Sir, density is 920.03 kg per meter cube.
920 you say.
Yes, sir.
Sir, 920, sir, but is it supposed to be, uh, I mean, like somewhere around,
What?
sir, 920, is it correct, sir? I'm little
It's
bit
correct.
confused. Okay, okay, sir,
It's
okay.
correct only.
Okay, sir.
920 point something.
02,
Uh,
sir. 03.
03 kg per meter cube. And what is this new value?
0.62128 into 10 power
0.621
28
to 8 into 10 to the power of minus
6.
6 meter square per second. See, 920 is correct. See, you write 920 here. It is following a decreasing trend. So 920 will fall under that decreasing trend. So 920 is correct. Okay, it is increasing trend. For the increasing trend on this side, you have the decreasing trend on the other side. So 920 will be a right one only. So anyways, let's write this 920 and this 0.62128 here. Mm. So here, instead of mu, I have to write for rho. It is 920.03 kg per meter cube. And for nu, it is 0.621. What is it? 0.621. 28 into 10 to the power of minus 6. 28 into 10 to the power of minus 6 meter square per second. If you want mu here, mu will be the product of rho into mu. Substitute this two things into this one here, into the Reynolds number expression. 920.03 into 0.62128 into 10 to the power of minus 10 to the power of minus 6 is the substitution. Now tell me what is the RE value?
204931.43.
2049.43.
31.43.
So RE value is greater than 2300 implies that it is a turbulent flow. Okay, the flow is turbulent. Now let me move to the data book. In my data book, let me open it again. I'll go to the internal flow problems. Internal flow. I'm sorry. Internal flow correlations you find out. In this, you have to go to turbulent. You have to go to turbulent. In turbulent, you have to move to the liquid metals section. Here, can you see the liquid metal section? In this liquid metal section, we have two formulas. One formula is for constant wall temperature. The other formula is for constant heat flux formula. Okay, so which formula you will use, this one or this one? You have to use constant heat flux, because in question he has clearly mentioned that this is a constant heat flux problem. Constant heat flux problem is given in question. So you have to use the constant heat flux NU formula here. So let me write that NU formula here. So NU is equal to 4.82 plus 0.0185 into RE. RED means at the diameter you have done, and then you have Prandtl power 0.8. So in this expression, you have the Reynolds number with you. You have just calculated it. Prandtl number, you have to get it from the data book. Okay. So in data book, you move to the page number 41. You will have this Prandtl value for sodium. Prandtl value for sodium is here. So using this, you have to actually interpolate and get the value. So for that, let me write it here. The 150 value is 0.0087, and for the 200, the value is 0.0075. On the value for 134.5, calculate. So again, the same story, 200 minus
9.0720.
x value is 0.
9.0072 into 10 power minus 2.
0.072. Am I right?
Yes, sir.
Right. Again, this is a rough work. So 0070, the Prandtl value, you got it. It is 0.009072. That is the Prandtl value. Now that you got the Prandtl value, you can go to the calculation of Nusselt number. The Nusselt number is equal to 4.82 plus 0.0185 into the Reynolds number value is 204931. 204931.43 into 0.009072 whole to the power of 0.8. All to the power of 0.8. So from this, tell me what is the Nusselt number value. Please tell me what is the Nusselt number value.
469.784.
469, huh?
Yes, sir.
That much you got it, huh?
Sir, is it 18?
18 would be correct.
Oh, okay.
From you do it again once more, one more time and cross check. It is plus here, and I have to multiply this thing. Power 0.8, you might have missed it. Please check it. Anyways, tell me what is 18 point value. 18 point
18.05.
05 is a Nusselt number value. From this, we have to get the H value. H D by K is equal to 18.05. In this HD by K, you know D value. It is given in question as 2.5 centimeters. Okay, it is known to you. K, you have to get from the data book. So again, move to your data book. At the end, you will get the K value. So for that, for finding the K value for 150 and 200, you take the values from the data book, and for 135, you extrapolate and tell me. 84.90, 81.41, 200 minus 134.5 by 200 minus 150 is equal to 81.41 minus x by 81.41 minus 84.90. What is x value?
98.9819.
85.98 you are saying.
Yes, sir.
Okay. Right. 85.98 watt per meter Kelvin is your x value. So again, this is rough work. So 85.98, let me write it here on the top right corner. 85.98 watt per meter watt per meter Kelvin. Watt per meter Kelvin is K value. So substitute the value here. So H into the D value is 2.5 into 10 to the power of minus 2 by the K value is 85.98. 85.98 is equal to 18.05. Tell me what is the H value?
Sir, Russell number I got
What is the value got?
14.17. Russell number, sir.
Yes, sir. Me
Probably
too, sir.
14 would be right.
14.17.
17.
1717.
14.17. Fine. 14.17. So H value is unknown here. Tell me what is the H value?
48740.
Tell me H value.
Is it 4874? Wait,
487
40.38.
40.38
40.38 watt per meter square Kelvin.
meter cube.
Okay, this is the H value. Okay, so Harish, please switch off your mic. Right, you got H value. So what do you want to get here? Actually, you want to get the ultimately L value you have to calculate here. That's what the question basically for you here. Here, you want to calculate the L value. So how do you calculate the L value here? For calculating the L value, we have the Q is equal to Q. That is Q is equal to MCP delta T and Q is equal to HA delta T. So we do that. What you get on this side is m dot into Cp into T minus T is equal to convection H into A into the delta T. Here the delta T is T wall minus T bulk mean. What is the delta T here? higher minus lower. T out is higher and T in is lower. 120 is this value, and let me write all those values here. So m dot value is given in question. Its value is 2.3. CP you have to get from the data book. Let's do it. And what is the out value? It is 149 degrees centigrade. Anyways, this is 120 degrees centigrade. The H value, it is 14.17 kada? I have done, no, it is NU value. H value is 48740.
Sir, is L value 0.36 meters?
Ah, yes. This is 48740.38, 0.38 watt per meter square Kelvin. And then A, what is A here? It is pi dl. It is pi dl. That is the area with which the fluid is interacting. In this d value, it is given in question as 2.5 to 10 to the power of minus 2 meter or 2.5 centimeters. So the L is the unknown value here, which you have to find out. Then in T wall, it's given in question as 200 degrees centigrade. T bulk mean we have found it out as 134.5 degrees centigrade. So everything, except this CP. CP you have to go get from the data book. So for that, we have to make use of this one here. So for the CP, for 150 it is 1357. For 200 it is 1327. For 134.5 we have to find the value. That is the X. It is 200 minus 134.5 by 200 minus 150 is equal to 1327 first, minus 1357 by 1327 minus 1357. This is X actually. Tell me what is the X value.
1366.3 joule per kg Kelvin.
Please repeat 1366
1366.3.
joule per kg Kelvin. 1366.3. Write it on the top right corner. 1366.3 joule per kg Kelvin. How to substitute it here? It is 1366.3 joule per kg Kelvin. So in this expression, you know everything except the L. L value is unknown to you. So calculate the L value. Somebody told me this L value. Repeat it.
0.3634 meter.
34 meters. Okay, that is your L value. So L is equal to 36.34 centimeters. Right? This is your answer. Yes. Shall we move ahead? So most of you have done it. Let me move ahead and tell you what is the procedure for solving a problem in an internal flow. Procedure for solving a problem in internal flow. Okay. See this procedure. I may not have told you explicitly, but implicitly it is followed till now. Till now, we have discussed about this procedure in various problems. Okay. So first step, what is the first step is found out whether it is internal flow or not. Internal flow or not. How do you find it out? You will find out the words like tube, pipe, inside the tube kind of words. Okay. So using those words, you will be understanding whether it is internal flow or external flow. What is the next step is? Next step is to find out the material. What is the material flowing or the fluid flowing? Only fluids flow. Okay. So that you have to find out in step two. The next step is to find out the bulk mean temperature. Bulk mean temperature is the bulk mean temperature is the average of T in and T out. That is plus T in plus T out by 2. That is the bulk mean temperature of the fluid that is flowing. In this, very important thing is Tn and T out are fluid temperatures. They are fluid temperatures. Okay, that is the T in and T out. Okay, then once you know this, next thing is properties are evaluated or taken, simply taken at T bulk mean. Okay, if, if there is a note here, there is an exception. If T bulk mean is not known from the data given in question, comma, then properties will be evaluated at the known temperature of fluid. This is very important. This temperature of the fluid. Okay, the temperature of the fluid, whatever known temperature, it can be either T in or T out or T average sometimes. It can be anything. So that's what you will do if the temperature bulk mean cannot be found out. Then there is a step three. Once you know the T bulk mean, you'll be calculating the properties. And what is the next thing? Step four. You have to find out whether the flow is laminar or turbulent. Okay. We will check whether the given flow is laminar or turbulent. For finding this, you have to use the Reynolds number formula. Reynolds number, there are so many formulas. Rho Vd by mu or Vd by nu, or you can also use 4m dot by pi d mu. These are all the formulas you are having here. So any one of the formulas you can take and find that the Reynolds number is less than 2300. That will implies the flow is laminar. If Reynolds number is greater than 2300, that imply that flow is turbulent. That is the thing in step 4. Once you find out the uh, given flow is laminar or turbulent, what is the next thing to do? The next thing to do is choose appropriate NU formula. The right way to say it is correlation. NU correlation. Okay. Which correlation you will choose? You will choose the correlation based on the case that you are having. Okay. If the case is fully developed flow, you will use the Dittus-Boelter equation. If it is something like the liquid metals, you will use the constant wall temperature, constant heat flux, or fully developed, or whatever the case that is given to you. You have to check for the case here. Okay, you may be given a non-circular section case. Okay, like that. So many cases are there: short pipe case, entrance region pipe, then entry length case. Likewise, so many cases are there. Okay, which case he is giving you the problem, you have to check with. Okay, and I already told you that the cases are many, so you have to choose the case appropriately from these page numbers, page number 132 to 137. From page number 132 to 137, you will go and you will choose the NU correlation. Once you get the NU correlation, what is the next step to do? Find out find out H from the NU correlation. So once you find out H, you can do anything he's asking you to find out in the given problem. Let me say he may ask you the Q value, or he may ask you the L value, or he may ask you anything for that matter. Area also he can ask. Okay, T out he can ask you. Okay, any question you can find out using the procedure laid out here. Is it clear? I hope it will be clear because we have already solved so many problems based on it. Okay. Have any questions? You can definitely get back to me on